Hi everyone! In today's video, I will show you how to use the main Git commands and how to work with GitHub to collaborate with other developers. My goal is to prepare you for the most common day-by-day tasks you need to perform as a team member. Not just to repeat commands, but to understand them and have a good foundation to advance your career. If you have no experience with Git or are new to it, I believe this video is for you. But even if you are already working with Git and GitHub, I'm sure you can benefit from it. So let's start. I hope you enjoy. The first thing we need to check is if you have Git installed in your computer. For that, we are going to use the command git version. If this is failing for you, please follow the instructions in the link I put in the description. Now, you can use git config list to show the actual Git configuration variables. This configuration can be overridden using git config global. Here, I'm setting the variables user's name and email address. And this is very important because when you commit change to a Git repository, this information is included in the commit message. This allows other people who are working on the same repository to know who made the change and how to contact you. Note that these two variables have been added in the Git configuration. You can also use git config global list to show only the variables you have overridden. The git global config file is stored in your home directory. Now you are all set to create your first local repository. In your projects folder, run git init. This command will create the hidden folder .git, which contains all the information about your local Git repository. It also creates an initial branch without any commits. You should have already noticed that my terminal prompt is now showing the current branch, which is main. Although the name main is arbitrary, it's common sense to use it for naming the initial branch. You may also find the name master. In Git, a branch is a pointer to a specific commit in the version history of a repository. A commit is an object that represents a snapshot of your changes. A branch is essentially a reference that points to the tip of a series of commits, allowing you to work on different lines of development independently. Each branch represents a separate line of development that can have its own set of changes and commits. In our projects folder, I also have another hidden folder named .idea because I'm using WebStorm as my editor. My goal in this video is to use WebStorm version control graphic interface to help you to visualize what we are doing. Let's take a look. Note that the main branch still doesn't have any commits. Head is a reference to the most recent commit to the current checkout branch. But before we create an initial commit, there is not much we can do here. So let's fix this. Since the idea hidden folder is specific to WebStorm, we don't want to version control it. So we need to inform Git to ignore it. For that, we need to create a .gitignore file. Keep in mind that any folders or files listed in this file will be ignored by Git. They are not part of your local repository. Now, you can use git status to check the status of a local repository. Here, Git is informing that the .gitignore file is untracked. To better understand that, let me show you a simple animation. The working tree is the directory that contains the files and folders you are working on. It's the place where you make changes to your code. The index or staging area is a temporary holding area where you can collect your changes before committing them to the local repository. A file is untracked when it has not been added to the staging area and it has not been committed to the repository. To move a file to the stage area, you need to use the command git add. Let's run git status again. Now, the file is staged and ready to be committed. To do that, you need to run git commit. The option M is to add a message in your commit. This message is very important to help the team to track changes. It should be concise, but clearly explain the changes you have made. Git status will show now that there is nothing to be committed, which means no files in the stage area, and that the working tree is clean. To check the history of commits in your repository, use the command git log. Now you can see the importance of having your name and email correctly informed. The graphic interface shows the same information provided by git log, just in a more friendly way. We have the snapshot with all changed files in the commit, and here this represents the first 8 characters of the commit hash code. Each commit has a unique hash code you can use to identify it. Now that we have our first commit, we can start to work with branches properly. Usually, you should avoid working directly on the main branch. This branch is considered the production branch. This means that it should always be stable and ready to be deployed. If you work directly on the main branch, you risk introducing bugs or breaking the build. So let's create a feature branch, which means a branch where we code a new feature for our product. Eventually, you can also have fixed branches as well, so you can deal with any bugs found in staging or production environments. To create a branch, you can use the command git branch, and then use git checkout to move to that branch. This new branch has the commits from the branch it has been created, in this case, the main branch. Now, the process to create files, stage, and commit them is the same as we did before. Let's create 2 commits in our feature branch. Using git log, you can check that we now have 3 commits, but keep in mind that those commits exist only in the feature branch. The main branch still has just the initial commit. In the graphic interface, each node represents a commit. If we go to the main branch, we can check that the changes we made in the feature branch are not here. To bring those changes, we need to merge the feature branch into the main. For that, we need to be in the main branch and then run git merge. Git gives us information about the changes. For instance, the number of files that have changed and how many changes for each file. The mode 10644 is to indicate that those files are regular files. Fast forward is a type of merge that does not create a new merge commit. Instead, it simply moves the branch pointer of the current branch forward to the tip of the target branch. This is possible if the target branch is a descendant of the current branch, which is the case here. Let's see this in the graphic interface. Now let's create another branch and repeat the process. But now, instead of using the commands branch and checkout, you can use just checkout with the option B. With this option, if the branch does not exist, it will be created before moving to it. Again, Git has used the fast-forward merge approach. Now, let's consider that you have started to work in a new feature branch named C and created two commits, features C1 and C2. But before you have finished your feature, another team member has created a feature branch D and merged it into the main branch. When you go back to finish your feature, the main branch is now different from that one you've checked out from. It has the new feature D. So, you can use merge here to ensure your code has the main last changes. In this case, you are merging the main branch into the feature C branch. Your branch code should have added the feature D by now. This way, it's like you have branched from the last version of the main branch. This is interesting because you know that your new feature will work properly when you merge it into main. Let's add a new commit in feature C branch and then merge it into main. Now, the main branch has the features C and D. Let's check this in the graphic interface. First, note the history of commits for feature C. We can clearly see the steps we have been taking. The graph shows from which commit you start to have a difference with the main branch, and that this difference was the commit feature D. Keep in mind that the commits feature C1 and feature C2 had not yet been merged into main. They existed only in the feature C branch. And then we can see a special commit that represents the merge of the branch main into feature C. If you go to the main branch, you see that is up to date now. For practical reasons, usually we want to use git log to check only the last commits. In this case, we just pass the option dash and the number of commits we want to list, starting from the last one. So here, you can use this to list the last 3 commits. The option raw allows to check which files have been added, modified, or deleted in each commit. Note that the character A indicates the file feature C3 has been added. It shows the file mode 106.44, which indicates this is a regular, non-executable file. And here we have the hashing for this file. We can also use the option name status to show only the status and the file name. In this example, we are using -1 to list only the first commit starting from the commit feature D. We are using the commit hash to identify it. Another important Git command we need to know is diff. We can use it in a bunch of different ways, but here you are going to use it to check the difference between your working tree and the last commit. This line displays the input sources of the diff. The prefix A indicates the old version of the file, and B indicates the new version. This line shows the short versions of the hash for the original and changed versions of the file, and the file mode as well. Git uses the unified format as a way of representing the changes between the 2 versions of the file in a human-readable format. The unified output format starts with a 2-line header. The minus symbol indicates changes in the original version file A, and the plus symbol indicates changes in the new version file B. Next comes one or more hunks of differences. Each hunk shows one area where the files differ. A diff only displays the sections of the file that have changes. Each hunk has its own header enclosed within double-add symbols. It shows the start line and the number of lines for each version of the file. If a hunk contains just one line, like in this example, only its start line number appears. In our case, the changes in the old version start at line 1 and the count is 1. This count is the sum of all lines having a minus symbol and the lines with no sign at all, which are considered contextual lines. These lines of code are shown around the changed lines to provide context for the changes. So it's easier to understand what has been changed. For the old version, the changes start at line 1 and the count is 2. Note that Git is summing up the contextual line 1 with the added line 2. The remaining content of the diff hunk displays the recent changes, minus for the lines that are being extracted, and plus for the lines that are being added. Unmodified lines have no sign. As this is just an example, let's restore the feature A1 file to its last commit version. Now, I will show you something you probably need as soon as you start to work in a team. Imagine that you are working on some feature branch, but before you are ready to do a commit, you need to check out another branch. Instead of forcing to commit incomplete code, you can simply use the command git stash. This command saves your changes for later use and then reverts them to your working tree. By default, stash will save the changes you have been added to your index using git add, and unstaged changes made to files already tracked by Git. So, untracked files will not be stashed. Keep in mind that an untracked file is a new file not yet added to index. In this example, both are new files, but file 1 is already staged. File 2 is still untracked. Instead of forcing to add file 2 to index, you can use the option -u, which means include untracked files. Now you can use git status to confirm that the working tree is clean. If you want to check if your ongoing work is really saved, you can use git stash list. By default, stash works as a stack data structure. We can use the command git stash pop to restore the last save, which is the top of the stack. If you need to use stash more than once, you can use a description to help you to identify each save. Let's do now something like what you find in the real world. After stashing again, let's check out the main branch and commit a README file there. After that, you can switch back to the stash demo branch. Then, merge the main branch into it. Now, you can use the stash list to check the saves and then pop to restore your changes. But instead of just getting the top of the stack, you can override this, informing the save you want to restore. Even if you delete the branch you were working on, the save will continue to be stashed. and you have the commands to drop a specific save or completely clear the stash. Until now, we've been working with just a local repository. It's okay to understand the basics, but to collaborate with a team, we need remote repositories. For that, we are going to use GitHub. If you still don't have an account in GitHub, you can pause this video and come back here later. Just click the sign up button and follow the steps. They are straightforward. But before creating our first repository in GitHub, let me show you how we can improve security. GitHub uses SSH or HTTPS to secure communication between the client and the server. Both are secure, but most companies use SSH. SSH means security shell or security socket shell. It works with a public and a private key. You must keep the private key in your computer and never share it with anyone. We will use the public key to configure GitHub. To generate the SSH key pair, we are going to use the command SSH keygen. The option T specifies the type of the key to create. Here, we are using the ED25519, which is the most recommended public key algorithm available today. The C option is to provide a custom key comment, the email in your case, which will be appended at the end of the public key. A default file name is suggested, but you can use a more meaningful name. This can be interesting if you have different keys for different purposes. The passphrase is an additional layer of security applied to a private key, but for this video, I'm not providing one. The command keygen generates a pair of files. The one without extension is the private key, and the one with the extension .pub is the public key. You should have noticed that the files have been generated in the .ssh directory. It is in the home directory, which is the same as the user directory. Keep in mind that the private key should be kept securely on your computer. It should never be shared with others. The public key is derived from the corresponding private key using that mathematical algorithm we choose when generating the keys. It is intended to be shared with others or made available to servers. So let's copy it and go to GitHub. After signing in your GitHub account, click on your photo, then click Settings. In the left side menu, click SSH and GPG keys, click New SSH key, fill in the title and pass the public key. Take care here to not use any additional characters, and then click SSH key. Now we are ready to create our repository in GitHub. You can click Repositories and then click New. Fill in the name and the description, and then you can set the visibility. You can set it as a private for now, but this can be changed anytime in the future. Then click Create Repository. Here you can check the repository's HTTPS and SSH URLs. Below that, GitHub explains what you need to do on your local computer. It gives us 3 options, but you want to follow the second one since you already have a local repository. So let's follow these steps. The remote add command is to link the local repository to the remote we have just created. Origin here is a shorthand name for the remote repository. And note that we are using the SSH URL. In the git branch command, the option -M is a shortcut to the options move and force. These options allow renaming the branch even the new branch name already exists. Git push is pushing the local main branch to the remote repository. The option U is to create the upstream branch, since you still don't have a branch named main in your remote repository. So you need to use this option just the first time you are pushing a new branch to the remote. And now you can go back to GitHub and check that everything has worked as expected. Note that we have only the main branch in the remote repository, since we pushed just that branch. In your computer, you can use git remote to list the remote repository. Now, let me show you what you need to do when you already have a remote repository and just want to start to work on it. This is a common scenario when you are joining an already established team. You just need to clone the repository. For that, we need to copy the remote SSH URL. The command git clone will create a copy of your remote in our local repository and link to it. Note that I'm using a temporary directory here just for demonstrating the process. After that, you are ready to work on the project. Now that we have linked the local to the remote repository, let's consider you need to work on a new feature branch. These steps are basically the same you have been using on the local repository, but before checking out to the new branch from your local main branch, you want to update it with all eventual changes that have been made to the remote main branch. For that, you can use the command git pull. It incorporates changes from a remote repository into the current branch. So here, you want to pull all the changes from the main branch in the remote repository origin. Just keep in mind that origin is a shorthand name for the remote repository. Git pull is a combination of git fetch and git merge. It calls git fetch to download the content from the remote repository and then calls merge to reconcile changes. In fact, git pull can use the command git rebase instead of merge, but this will be a topic for another video. Now, you can create a new branch, add or modify files, and commit the changes the same way you have been doing. But note that this feature branch exists only in the local repository. We still need to push this branch to the remote repository. For that, we need to use the same git push command we used before, including the option U to create the upstream branch. Now, you have the feature branch in both repositories, local and remote. Let's check this on GitHub. If you have finished the changes in your feature branch, you can now create a pull request in GitHub. This is a request for one or more members of your team to approve the changes you made before you merge them into the remote main branch. Usually, this step is mandatory, and you will be able to merge your changes only after the team's approval. Note that GitHub is already informing a recent push you made, so click Compare and Pull Requests. You need to provide a title summarizing the changes and additional comments to help your team members to understand what you have worked on. Most companies ask you to add more detailed information and the link to the task you are working on. So you need to check with your tech lead about this. You can also assign reviewers to your pull requests. In that case, they will be notified about the request for the review. Then just click Create Pull Request. We can add rules to make the approval mandatory before you can merge into main. Usually, the company you are working for will have these rules already defined. Note that the Merge button is already enabled since we don't have these rules. Most companies have configured a continuous integration. Usually, when you create a pull request, your branch is automatically sent to a CI pipeline that is gonna build your branch, run the tests, and check that everything's okay with your code. GitHub checks if your branch can be merged automatically or if there are any conflicts you need to solve manually before merging. A conflict happens when team members make different changes to the same line of code or when one member deletes a file while another member edits it. you can assign yourself or other team members to this pull request to indicate who is working on it. The tab Files Changed uses Git diff to show all the changes in your branch. A reviewer can add comments with questions or suggestions for a specific line of code. And you can answer the same way, which is a great way to collaborate with your team. Reviewers can finalize their review with three possibilities: approval, just comments, or request additional changes. In that case, it will block the merge. You can't approve your own branch, but remember that we don't have any blocking rules. Here, you can check all the pull requests. By default, only those with status open are shown, but you can use different filters. For instance, you can search for a closed pull request. Let's now click Merge Pull Request and then confirm merge. And that's it. Your changes should appear now in the main branch. Usually, after merging a branch, you should delete it from the remote repository. But check this with your tech lead. You can now confirm that your changes are really incorporated to the main branch. For the last part of this video, I'll show you how to deal with conflicts. For that, you will create a new feature branch from your local main branch, but without using git pull first. Keep in mind that the local main branch still doesn't know about the changes we've been making in the remote main branch. Let's add the same file feature with another content and push this to the remote repository. This should create a conflict and block the option to merge automatically. When you create the pull request for this branch, GitHub already informs the issue. But note that you can still create your PR. But now, you need to resolve the conflicts to enable the merging. First, let's use GitHub for that. Git uses special symbols named conflict markers to indicate the conflicts in a file. This marker indicates the changes that were made in the current branch, in your case, the feature issue. This marker is a separator between the two sets of changes, and this indicates the changes that were made in the other branch, in your case, the main branch. You need to delete the conflict markers and make the change you want in the final merge. Don't worry, here you are doing this manually, and it's okay for a small change. But the main IDEs, like WebStorm and Visual Code, have more friendly tools to help you with this. Then we can commit the change and confirm that the merge button is now enabled. But instead of merging this branch into the remote main, go back to your computer and do all these steps again. But now you will resolve the conflicts locally. Note that when you check out to your main branch, Git already knows that there is a difference with the remote branch. It's informing you that the local main is behind the remote main branch by 2 commits. Again, to reproduce the conflict scenario, you will not use git pull. Create a new branch and follow the same steps until you have the conflict message from your pull request. Then go back to your computer. Now, you can use git pull to merge the remote main branch into your feature branch. However, as the last commits in the remote main branch have added the same file you have in your branch, Git is informing you about the conflict. You can check that the feature file now has conflict markers indicating what needs to be resolved. Just do the same thing you did before. And then commit and push the change. The merge button in GitHub should be enabled by now. And that's it for today. This video is a bit longer than usual, but I believe it really can help you to have more control about how to use Git and GitHub and be more prepared for teamwork. If you like it, please give it a thumbs up and don't forget to leave your comments below. Thanks for watching, and I see you in the next video.